Agora eu gostaria de apresentar o Tim Caswell, que vem para a gente falar sobre uma jornada de saindo de Node.js para Lua. Parece que vai ser em inglês.
Bom dia. I don't speak much Portuguese, I'm sorry. I used to be fluent in Spanish, but it would be terrible now, so let's not. So, my talk is about comparing JavaScript and Lua. Which is why I wanted this background information, because there are a lot of similarities and a lot of things that are very different. So it seems like it was mostly just the same trade-offs. If you want to make an embedded scripting language, you make a lot of the same decisions technically. So for those of you who don't know me, I'm one of the early Node.js contributors. I discovered it in 2009, Googling for V8 on the server, and wrote a lot of the early libraries, and kind of got frustrated with it. Because, yeah, it's JavaScript. It has good parts and bad parts. So I had this crazy plan back in 2011, I think. I was working at WebOS, you know, those little tablets that run Linux. We use Node in the back end for the dbus, like the dbus in Linux. So when you'd open the Contacts app on the tablet, it would launch a Node process, go to the database, and give you the contacts accounts for that tablet, which was really, really, really slow. V8 on a mobile device is not fast. We're talking multiple seconds just to boot the process, and then multiple more seconds to compile all the JavaScript, and then the UI shows you stuff. So that's a problem. So I had this great idea. What if I used Lua instead of JavaScript, but kept everything else? So on the Node team, we'd written this thing called libuv, which takes all the asynchronous I/O and moves it to a C library. Works in Windows, works in Linux, works in Mac, and it's non-blocking I/O for the highly scalable event systems like Nginx, that type of event loop where you never block on I/O. And Luajit is a very fast VM implementing Lua, 5.1-ish, it's kind of a language fork at this point, but it's Lua still. And so I said, hey, let's just pull out V8 and put Luajit in. How hard can that be, right? Yeah. So this is basically what Node looked like at the time. There was libuv, HTTP parser. These are all C libraries. OpenSSL, of course, for crypto, zlib for compression, and then V8 to run the JavaScript. So this was my design. Same thing. Oh, let's do Luajit and run Lua instead of JavaScript. It'll be great. Why Lua? Well, it's much lighter weight. Even Luajit, which is heavier than the Lua made here, is still a lot lighter than V8. You ever wondered why your browser uses gigabytes of RAM? A lot of it is the JavaScript engine. It's really, really, really heavy. It's optimized. Everything has trade-offs, and in V8, the trade-off is we're going to use all your RAM to make your JavaScript as fast as possible. That's the trade-off, because there's benchmark wars, and they want to win. Lua cares more about embedded. It's more conscious of memory. Also, I don't like C++. I like C. And in V8, you have to write C++. It's a pain. There's smart pointers and all sorts of weird stuff. And coroutines. If you've done any Node.js, you know that callbacks are kind of painful. Every time you do I/O, you have to give it a callback as your continuation, which then gets called. Whereas in Lua, you can just pause your coroutine thread and then resume it later. You can get blocking I/O, but still have a fast, non-blocking event system. And then Luajit has the really nice FFI, and I wanted to make things other than websites. I brought some Node MCUs with me if you want to see those. And I've done robotics on Raspberry Pis using Loveit. And not just websites. I want to work on more embedded spaces where you don't have a server with gigabytes of RAM. So I started the work. First, I had to learn C, because I didn't know C. I knew I liked it better than C++, but that was about all I knew. And I had to learn libuv. And back then, there were no docs, so I cloned it and read the header file, because that was the documentation. And joined the IRC channel, and then I got hired by this company called Cloud9. They were collecting all the Node people. They were trying to, I guess, do a takeover of Node, I don't know. But two of the people they hired happened to be the two guys that wrote most of libuv. So they're now my coworkers. So I really get to know the library, ask them questions. It was great. So here's basically what a server would look like. You'd allocate your TCP object, initialize it, bind it to some port. You would tell it to listen, give it a callback. libuv is callback based, but in C, so they're function pointers. There's no closures. And then you run the event loop, and the run function will block. And while it's blocked, the event loop will call your callbacks. That's how it works. And so this is what the on connection looks like. You get a server object, some status. You got to create a client. You have to initialize it. You have to accept the client. All this error handling and typecasting. It's pretty verbose. And then you start reading, and every time a read event happens, you get a read callback, which looks like this. So you got your read callback, and you're printing, and more error handling, and you have to close it, and always close it, even in error case, or you'll leak resources, bad stuff happens. And you have to also manually allocate memory. libuv lets you handle the allocation, so there's a callback for that. Got this error helper, this on-close callback. So that was, I don't know, 40 lines of code to just make a server that listens and prints the connection. Now, if you've done low-level C code, this looks nice, because this sure beats the stuff in the POSIX API. That's really low level. libuv is the jQuery of C. You have one nice high-level API, works the same in Windows or Linux or Mac, doesn't matter. Under the hood, it will use epoll or KQ. It's actually a nice library. It's not the most efficient thing in the world, but it gives you a nice cross-platform layer. Well, I didn't know Lua either. So I had to learn Lua. If I want to use Luajit, I should probably learn Lua. So I bought this book, great book, read it, joined the mailing list, joined the IRC channel, and then the manual online is very, very handy. It's got, like he said, the entire C API, all the Lua functions, they're all documented. That was very helpful. So that was enough to learn Lua. It's a simple language. It's not hard to learn. So then there was the question of, I have all these JavaScript APIs in Node, how can I redesign them for Lua? Do I have to make any changes in the design? And it turns out the two languages are almost the same from this point of view. Objects and tables are more or less the same. You have string keys in JavaScript which point to some value. You can do that in tables. There's no inheritance in Lua, but with meta tables you can do it real easy with the index meta method. One tricky thing, you can't have nil values in a table but still have the key, whereas in JavaScript you can. You can have a string key with a null value. And when you're dealing with external JSON APIs, that's sometimes a problem, because doing that in Lua is hard. And so you have to have a fake value that counts as null, that holds a place, and there's some minor differences. There was no this in Lua, thank goodness. I hate that part of JavaScript. Instead, we have the colon syntax, which inserts the self variable. It's really elegant, really simple. Doesn't actually change the core language. It's basically sugar. So then I designed an object system. I'm sure a lot of us have done this, because I needed a way to take all my prototype-based JavaScript APIs and convert them to Lua. And so this is a very basic system. You make an object, you can extend an object. For example, here's a rectangle class. And I can make an instance of it, I can call methods on it. This is all plain, pretty simple Lua. And then Node has this thing called the event emitter. And so an event emitter is an object which you can register events, you can unregister, you can emit events, and using the tables, it's actually not that bad. It's pretty simple code. And so here's where the fun happens. On the left is JavaScript, on the right is Lua. When I say they look a lot alike, you change the curly braces for ends, remove the semicolons, and you're pretty much done. At this level, they look a lot alike. They both have closures. They both have first-class functions. Until recently, they both had one number type, and that was double. And it's probably because you can do the NAND packing with the pointers. It's a neat technique. A lot of similarities in the languages. So I proved that it can be done. I proved that languages are compatible. I've learned Lua, I've learned C, but I have to actually finish my implementation for it to be useful. And this is where it gets hard. libuv has a lot more functions. We've got all the file system functions for non-blocking file system access. There's a lot of random miscellaneous things, and since then, libuv's added a whole lot more functions. It's crazy stuff, like interface addresses will tell you all the network cards on your machine and their MAC addresses and their gateways and all that information. Things that plain Lua can't give you because it's portable. libuv will provide you with this extra system-specific information. And libuv internally has this object structure. There's a base object called the handle. Even though C is not object-oriented, libuv is. They just use structs and typecasting and unions so that your things line up. It works. So a stream is a subclass of a handle, TCP is a subclass of a stream, and so, as you saw before, when I want to make a server, I create a TCP, I'll call listen on it, I'll call accept on the child, and all these various types. UDP used to be part of stream, but now they've moved it out. They decided UDP is not actually a stream. It's something else. So, binding libuv to Lua, I'd written 12,000 lines of C code. I've never really written C before, so that was fun. What's Lua 5? Was that like 15,000 lines of code? So I've almost doubled it just by writing bindings to an existing library. Lua's tiny. So I still need to write bindings for HTTP parser, which is Ryan Dahl's HTTP state machine. C-Arrays is a non-blocking DNS library. OpenSSL, that's a beast. Writing bindings for that. I know there's existing ones for Lua, but a lot of them don't take into account the non-blocking system that I'm doing, and I didn't even know what was available, so we had to write our own. And zlib, that one's not too bad. And then there's the problem of the libuv API is not the same API exposed to JavaScript. There's a lot of abstraction in between. And so I still need to write all the abstraction in Lua, whereas in Node it's written in JavaScript to bridge that gap. And so that was over 5,000 lines of Lua code, which is a bit of code. And then I have to find a cross-platform build system so that people can build my tool on Windows and on Linux and on Mac and on Raspberry Pi and on BSD and FreeBSD and OpenBSD. And people use this on all sorts of crazy stuff because Lua is portable and they want to do it. And then JSON was kind of tricky, so I had to find a JSON library that worked. There were a few of those. Now, I was doing all of this by myself in my free time. This takes a while. I mean, I had plans of using it at work for WebOS, but HP shut us all down anyway, so I had to get a new job. And this is where I was saved by the community. Rackspace has this product monitoring that they use. It was actually one of my old friends' startups. Back in the early Node days, there was a company called CloudKick. And what they did is they kicked your cloud server. They'd pull it every minute or so, and if the server didn't respond, hey, your server's down. I'm going to send you an email. That was their startup. Rackspace bought them. It was all written in Node. And they wanted to add a new feature where they could run an agent on the inside of the box and do health checks from the inside, like your hard drive is full, your memory is full, your CPU's pegged, and send alerts on that. But they don't want to run Node inside a customer's VM because a Node process can easily use 100 megs of RAM doing nothing. And that doesn't make customers happy when you're charging them for that RAM. But since their entire project is written in Node, they want their developers to have something similar. They said, hey, what if Node was written in Lua so we could use less RAM? And I said, hey, I got a solution for you. So they joined me, and there were a few other contributors all over the world. We got Russians, we got people from China, we got people from Brazil, from Spain, and they helped me finish Loveit. I didn't have to worry about the Windows build system. Someone else took care of that. I didn't have to worry about writing OpenSSL bindings. Someone else took care of that. That's a lot of work. And they helped finish my object system, and they wrote most of the Lua sugar layer that bridges libuv and the Node APIs. And so we actually finished it. Loveit was 4 times faster than Node.JS and used 20 times less RAM. And on mobile devices like my Raspberry Pi or my tablet, the process started instantly, like 100 milliseconds or less, whereas Node would be 4,000 milliseconds or something ridiculous. And we pretty much had a clone of Node in Lua. So I gave a talk at NodeConf. I was the closing speaker. I went around the world telling people about it. And that was Love It. Rackspace took over maintenance. I had other jobs. I was doing my own startups. I wasn't working on it anymore. Now let's fast forward to more recent times. So this was past history, 2011, 2012. Since then, I haven't touched it for a while. Now Love It 2.0. We got some problems. This project is better than Node, right? It's Lua, it's faster, it uses less RAM, it has coroutines, it has FFI. Who would not use this instead of Node? You would all use this instead of Node, right? Well, actually, Node people don't like Lua, and Lua people don't like callbacks. So no one likes this, except for Rackspace. Because Rackspace wants Node in Lua, and that's what it is. So I had a problem. I could just throw the project away or fix this. There's a lot of good stuff in here. In the Lua community, I've seen a lot of people want access to good, fast event servers. They want web frameworks. They want to use Lua instead of JavaScript or Ruby or Python or whatever to make their web apps. And I have the technology to do it. I just got to make it accessible. So after running completely out of money on my failed startups, Rackspace calls me up and they say, you know, we use your product. We could just hire you to work on Love It. I'm like, oh, that's a good idea. So they hired me almost 2 years ago now, and to work on the monitoring team, the one that uses my Love It agent. And so I spent almost the first year of my daytime work rewriting Love It from scratch, from the ground up. So I'm writing a lot more C now. So first, I wrote a project called Love, which is Lua libuv bindings. That's it. Nothing else, just Lua libuv bindings. And I used the latest libuv because it had changed a lot since Love It 1.0. It now has proper documentation, not just a header file. It has its own organization on GitHub. It's a real project now. And Love is nice. Like sometimes I just use that directly, just Lua rocks install Love and go from there. It's pretty nice. And then I had the problem of I have all this Lua code that's sugar, and then all these C bindings, and anytime I want to change the sugar layer, I have to recompile. And if one of the strengths of Lua is you don't have to recompile, then I'm killing myself having to recompile to change my Lua. So I made this project called Lovey, because it's halfway between Love It and Love. Bad name, don't do that. Autocomplete will hate you. And basically Lovey is all the C code. Everything that could possibly be moved to the C side is in this one binary, one precompiled binary. And then Love It itself is 100% Lua. Just embeds the Lovey binary, and then everything else is Lua. And so that way, I don't have to recompile anything when I'm working on Love It, which is nice. And then I made a package manager, because everybody loves package managers. And this one's called Lit. It's the Lua Invention Toolkit. It's a package manager and a building toolkit. So as I was mentioning, Love is actually pretty useful on its own. My main target audience was the Lua community. People wanted access to libuv, but they didn't want to have to use Love It with its opinions, with its own runtime, with its own module system, because I replaced Lua's require, wrote my own, like it's not compatible. Whereas with Love, you can just Lua rocks install Love and require it, and it works with Luajit or any Lua. I don't know if it works, I think it works with 5.3 now. And I made the package format of all of my libraries that I've published compatible. They just return their exports as a table. And then I wrote a blog post explaining how to do this. I posted it to the Lua L a couple months ago. People seem to like it. So you can use a lot of libraries I wrote for Love It without using Love It. You can just use them with normal Lua. And there was a bit of interest. People kind of like that. So now what do I do with this abomination that is Node.js and Lua? Rackspace still uses it. They're my employer. I can't throw that away. So I took this API that only they want for the most part, and I pushed it to user space as a library. It's just a meta package in the Lit ecosystem. And it's known as Luajit/Luajit because everything in lit is prefixed by the publisher. It's a little different than Lua Rocks. And then I started writing all my new code taking advantage of Lua. Instead of trying to copy Node in Lua, I'm trying to design it from scratch using Lua's strengths. This worked much better. I can use coroutines for all my non-blocking I/O, and within my code, it's blocking. I can wait for the result, get a return value, and it's much easier code. And with the whole Lovey system where Lovey and your app are separate, if any of you have used, there's a small Lua gaming framework called Love, L-O-V-E, and the way you build your app is you just zip your Lua files, cat it with the binary, and that's a file. Lovey works the exact same way. You just take a bunch of Lua files, zip them together, cat it on the end, and you now have an app that you can distribute. You can have single file binary for your web server. Now, if you don't want to bother catting and zipping, the lit tool will do all that for you. But you can build standalone binaries in Loveit now without having a C compiler on your system. Just download my pre-compiled Lovey binary, and everything else is easy. You can do this on Windows, on your relatives. You can go to the store and build on one of the display laptops. I don't know. Crazy stuff. So here's what some of the coroutine APIs look like. These are much nicer. So I made this net API. You can create a server, tell it where to bind to, and every time a TCP client connects, you get this read and write function. Those are blocking functions. When you call read, it will block your coroutine until there's data and then return the data. When you call write, it'll write the data and block until it's flushed. And so this is an echo server. It just reads chunks and then writes them back. Very simple. And when read gets the end of stream, it will return nil. And then when you write nil, you send an end of stream to the other side. So that's how I map from TCP to Lua. Very, very simple, maybe too simple, but it's a very nice interface for a lot of stuff. And then here's a client. So this connects, gotta put it in a coroutine. So this connects to the server, waits for the connection, gives you the read and write functions, and then you can write a message, make sure it echoes back, close your side, make sure the other side's closed, and then close the server. This whole one file is a TCP client and server standalone application. You don't have to embed this in Nginx. You don't need OpenResty. You don't need a framework at all. You can just embed a small Lovey binary to the front of this, and you have a single executable for whatever you want. If you want to go up a level of abstraction, I wrote a HTTP framework called Weblet. It's kind of like Sinatra or Express, if you've used any of those. It's got middleware. There's a logging middleware that logs all the HTTP requests. The Weblet auto headers will make sure you have proper HTTP headers. Like according to the spec, you're supposed to have date and various headers, and it adds those in for you. You bind. Now here I'm just returning the table, so I'm doing lots of chaining, taking advantage of Lua syntax. And then this is a custom route, match a path. We got some named parameters, and then I'm responding with hello and whatever the name parameter was. Thank you. And then here's a client. We have the Coro HTTP library. This is for making HTTP requests. Just give it a URL, tell it to connect, make a GET request. It'll give you back the response head, which contains the status code, the headers, and then whatever the body was. So these are some very high abstraction level APIs, and these are all written in plain Lua on top of the primitives provided by libuv. But you don't have to use all the abstractions that Node invented for JavaScript because they don't make sense in Lua. The languages are similar, but not that similar. And then you want WebSockets, perhaps. Well, there's a WebSocket middleware, and you can just .WebSocket, listen on a path. You can even specify a sub-protocol in WebSockets. And similar, you can read and write. You can echo the parameter from the URL. And this is a WebSocket client. Again, it's similarly simple. So what about this lit thing I keep mentioning? Why am I trying to compete with Lua Rocks? This is craziness, right? I mean, to be honest, I don't understand Lua Rocks very well. It's a different ecosystem than I'm used to. And when I don't understand something, instead of understanding it, I just make my own. I'm bad. But there's some really nice parts to this. We can learn from each other. So originally, this was Loveit's version of NPM. In Node, NPM is the package manager. So in Loveit, you have lit. It's also a local caching proxy. It's also the server. The production lit server, the repository, is just a lit process. That's it. Whereas if you go to Node.js, you have to have this big, huge CouchDB cloud and these replicators and load balancers. It takes a full VC-funded startup to run the NPM server. Whereas my server is just one process, just one binary. And lit also will zip and concat these files for you, so you don't have to do that yourself. Because on Windows, that's actually kind of tricky. So it can be used to install a package. So if you want to install Weblit in a package, you do that. It'll connect, it'll include dependencies, all that fun stuff. The output tree will look like this. So this takes the same pattern as Node, where all your dependencies are local to your code base. So there's a local folder called deps, and there's all your dependencies. Most of them are single files, some of them are folders. I support both. And you can also give it the URL to an application that's been published to lit, and do lit make. Sorry, it's small. And that will actually download the metadata for your package, find out which version of the Lovey binary you want, detect what platform you're on. It will download and cache the right Lovey binary for you. It will compile all your Lua. It'll actually compile them to bytecode. And if the bytecode is smaller in the Lua, it will include the bytecode in the zip file instead of the Lua. Because if you have a lot of comments in your code, even though Lua is more terse, the bytecode will still be smaller because it strips out all the comments. And so you say some of these it's stored, some of these it compiled. And it puts all those in one big zip file for you, concatenates them together, and now I have this single file WSCat. And if you run it, it's an executable. If you ask the operating system what it is, it's an executable. If you ask unzip what it is, it's a zip file. Same file. It's executable and a zip. And all you got to do is lit make, give it some URL. You can give it lit URLs, you can give it HTTP URLs, you can give it GitHub URLs. It supports several different formats. And one important thing here, this snapshot. If you're familiar with NPM's shrink wrap tool, the problem that NPM has in Node is when you publish a package, you have lots of dependencies. And maybe your dependencies change after you publish it. And maybe those changes break things. So when you're distributing an application, you want the dependencies frozen at the time you published it. If there's a bug fix deep down 3 levels, I don't mind just republishing my top level once. And so what lit will do automatically is every time you publish an application, it will take a snapshot of your dependencies, save that as a Git tree, and store that in the metadata. And so when you're doing lit make, it will just use that snapshot of Git tree and use that instead of whatever the current state is. And then of course, this is how you make a server. That's it, lit serve, done. And you can take a different lit client, and instead of pointing to the main one, you can point to this one. It'll pull the data from here, that'll forward the request, they'll be cached locally. All the metadata in lit is content addressable Merkle tree, what do you call it? It's the same as Git. It's all hashes and trees. And so I'm out of time, and I was going to say, I learned a few lessons doing all this. Lua as a language is compatible with the Node.js APIs. The languages are similar enough, you can get away with that. I learned that Luajit is a lot better than V8 on a lot of technical levels. I learned that calling C code from Luajit is a lot faster than calling C++ code from V8. In Node, I had to write my own MD5 function in JavaScript because that was faster than calling the OpenSSL MD5. There was just so much overhead calling the C++ function. With Lua, we don't really have that problem. It's a cheap call. And then coroutines are awesome. So Lua is its own language with unique strengths and abilities. Is it time for questions? I have a couple more minutes. Okay. Do I have a couple more minutes? Okay. 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 So just one more thing. This is my current project that I'm working on. I'm still working on Loveit. As I'm bringing it full circle, I'm going to port Loveit back to Node. Because why not, right? Or rather, Lovey, because the Loveit stuff doesn't make sense. And so I have a new project called nucleus.js that's a single binary that has all the C code, and you append a zip file full of JavaScript to it. And it's engine agnostic. You can use V8, SpiderMonkey, Chakra, duct tape if you want embedded. Duct tape, I think, is even lighter weight than Lua. I don't know how they did that, but they have a JavaScript ES5 implementation that runs on microcontrollers. It's crazy. So all of those. And yeah, otherwise it works like Lua. You just write your JavaScript, zip it together, and that's one of my current projects. So thank you all, the Lua community, for giving me such a fun journey.
Perguntas? Questions? No one.
You can try to ask in Portuguese. I might understand.
Hello. It's interesting for me you to show about the web server, because I was actually last week looking through OpenResty and Nginx with Lua, and it's not very motivating if you are just a Lua developer using scripts to try to go to the server side and have to set up everything. And your example is just very, very neat, very simple, and very direct. My concern is about security. If you have any recommendations when you are running like your web server using Luajit or the new one that you showed, the core. I need to have any extra security actions to make sure that my web app run without problems.
Right. So, I mean, security-wise, it's no different than Ruby on Rails or Node.js or any of those. The Lua binaries, there's two flavors. There's minimal and regular. Regular includes OpenSSL. It's about 3 megabytes. And with that, you can use my TLS libraries. So you can make a full server with full TLS, its own HTTP termination, and you can do your own passwords. You can do, I mean, whatever crypto you want, the primitives are there. In production, what I tend to do is just run it behind a load balancer, and then let my load balancer do the termination. So the Lua.io server runs behind Nginx, using Nginx for the TLS, and then the Lua server is just serving plain HTTP to that, but over localhost, so no one can get to it. I mean, I've got middleware libraries for HTTP basic auth. It wouldn't be hard to make authentication schemes for other systems. I mean, it's a very flexible system. Anything can be done. There aren't a lot of libraries yet, but there's nothing inherently insecure about it. It's just a platform. It's a lot like Ruby or Python or any of those.
Any more questions?
I've been following the project since the beginning, and when I first found about it, it was just a dream come true, because just like you, I thought I was using Node.js to work, and I wanted to use Lua instead, and it seemed perfect. And my question, and especially now, when you have Luajit and Lit and everything, I'm still in the process of trying to migrate things to Lua back from JavaScript. But my question is, how do you see now the reception or the? Do you see it used in production at other places, or how the community is responding to it? Because
Right.
From my point of view, it should just replace Node, just like probably you thought.
Right. So Luajit's not very popular still. There's a few startups here and there who have used it. I don't have a lot of visibility into who's using it. People don't ask me questions unless things break, and I try not to break things. Though it's a great way to find out who the users are. Change an API, and you find out. I do know there's some startups and some bigger companies using it. A few people are using it for web. I mean, the main ones I know is my websites. I have several websites using Loveit. Rackspace doesn't use it at all for that. It's for the agent that lives inside the machines. There's no web server at all. I mean, compared to Node, yeah, you get a much faster runtime, you get much less memory, you get almost zero community. There's maybe 200 packages in the lit repository, whereas Node.js, that many are published every hour. I don't know, something ridiculous. So, I mean, it's a trade-off. If you want stability, if you want a mature community, don't go to Loveit. If you want a simple system that gives you nice non-block NO, if you just want to play around, it's really good for that. It's a fabulous prototyping framework. It's really good for that, actually. I use that work to prototype projects here and there. I just throw them out with Loveit, and they're amazed at how fast I can get projects out the door, because all the tools are there. Lua is a simple language. I don't know of many production systems using it for the web, if any.
We have time for one more question.
Fica meio chato. Perguntei também. Anyway, I see that you, in the WebSockets example, for instance, you could choose your own protocol on top of WebSockets.
Right.
I saw a case here in Brazil where they use MQTT, the IoT protocol,
Yeah.
Mostly used for IoT, on top of WebSockets to implement a chatting system with the browser. Is there a way to extend to use such non-conventional protocols like this one?
Yeah. So the net library that I was showing you, the coroutines, has the system of nested encoders and decoders. And so it's got the HTTP encoder decoder that's the handshake, and then it upgrades to the WebSocket framing encoder decoder. And then on top of that, you can have one for your application-specific protocol. The one that was on the slide, that's just a string. And it means whatever you want it to mean. The client will say, hey, I want to speak one of these sub-protocols, and the server will say, all right, we're speaking this protocol. And it's just a string. But then on top of that, you can implement anything you want. You can treat the WebSocket transport like a TCP connection, for example. So you could write a library that implements the MQTT on top of WebSockets. I don't think anybody's written one yet, but it shouldn't be that hard. I've got lots of libraries and generic tools that let you layer protocols on top of protocols. So it shouldn't be hard.
Well, thank you, Tim. We don't have time for questions anymore, so please give a round of applause. So now it's the coffee break time. If you go outside, you'll see a table outside with little boxes. You can grab one. We will be back by 11:20 and not 11:15.